I hope everyone is here. I'm not so sure about the audio though. Is our audio fine? If you are here, the stream has already started. So I'm not so sure about the audio. Guys, what do you think about our audio? All right, the audio is fine, people. I was just checking. So as you can see there is a QR code for the WhatsApp group. I've shown you this QR code so that you can able to scan it and join the group, because I'm gonna share the video. I'm gonna share, the question paper that we will be doing here on that WhatsApp group or channel. So make sure that you join the channel, and then you're gonna download that question paper, because I wanted to create a link for you guys to download underneath, but I didn't have enough time to do such. So just join the group there, because I share information on N5 question papers and N4 as well, mostly N4 question papers, videos, and also some information that is relevant to mathematics. So guys, I'm moving from this now. I'm going straight to the question. So I would like to know from you guys. You can type there on the live chat, where are you coming from, which province are you coming from, what college are you coming from, guys. That will be highly appreciated. So this is the question paper that we will be doing. This is the question paper that we did last block, which was written on the 12th of March 2025, guys. So it was really not that challenging, but it really needed you to know what you're doing. So on this video, we'll be doing question 1, because we have a challenge with our mic. It tends to switch off, guys, after an hour. So I hope our question 1 is gonna be an hour. All right, let me just scroll down so that you can see the question. By the way, this is just the cover. So before I scroll down, as you can see, there is written Gauteng and Free State region, right? So this, it's a common paper for Gauteng and Free State, but it doesn't matter even if you're not from those provinces, because maths, it's maths at the end of the day, right? I'm just hoping that you'll be writing after or before the 16th, because people from Gauteng and Free State, for test 2, we're all gonna write on the 16th, right? So let me just scroll there. You just scroll there. So we're gonna do other questions maybe tomorrow, but we'll discuss, guys, when exactly we're gonna do that. All right, so here's our question 1 here, guys. Hope you can see. I would really appreciate it, guys, if you do comment there on the live chat, that you can hear me and also you can understand what I'm saying, because it really it has a lot of technical errors if I don't pay attention to them before we start. Can you understand? Can you hear me, and also can you see the feed on the screen before we start there, guys? Right. So I'm waiting for you guys to comment on the feed. Can you hear me? Can you see? Yes? No? Which is it, guys? Which is it? Right. I don't see any. I don't see any. I don't see any comments here. Let me try to view the comment section, guys. I don't see it. Oh, I have to go to my laptop now, which is, oh yes, this, you say you can hear me, guys. I'm trying to use another device, because this one here on the phone, on the laptop, is gonna ruin our view. All right, people. So here's how I'm going to do these question papers, or these questions. In fact, I am going to solve a problem, and then when I'm done, I'm gonna try to pay attention to your questions. So try to hold on to the questions before we actually continue, guys. Right, let's do it. All right, so I can see the live. I can see the live, guys. So let's start with question 1. So as you can see, question 1 is differentiation, guys. Right, now I'm gonna choose question 1.1 here. So they want us to expand this expression here, where we have open bracket 3 minus 2x to the power of 4, if you close the bracket. so that they want us to expand it to the fourth term using the binomial theorem. Now, this one here, guys, it looks tricky, but really it was not that tricky. So I'm just going to rewrite it here on the side, and then we try to solve it very quickly, guys. Right, so 1.1, right? So we have 3 minus 2x, and then we have to the power of 4. So let me just create a space so that we can able to do this. Right. So what you should know about expansion, guys. What you should know about expansion, like they say, you must expand it to fourth term. In your level, you're supposed to expand it to the fourth term, guys. Beyond that, it's a waste of time. Even if they don't specify, always expand it to the fourth term. So you need to use the binomial theorem. So we have this formula here for binomial theorem, where we have x plus h to the power of n, right? And then when we expand this to the fourth term, we have x to the power of n plus, then we have n, x to the power of n minus 1 multiplied by h plus, and then the second term we have n multiplied by n minus 1. This is divided by 2 factorial, guys, right? And then we have x to the power of n minus 2, and then we have h to the power of 2, right? The last term is going to look like this. We have n to the power of n minus 1, and then we have we have n, and then we have open bracket n minus 1 close bracket, and then we have another n minus 2 close bracket. This is divided by 3 factorial, and then we have x to the power of n minus 3 h to the power of 3. Let me highlight to you guys the terms. Remember, they said for expand it to fourth term. So the first term is this one, the second term is that one, the third term is this one, and the fourth term is that one, guys, right? So don't go beyond this. It's really not that necessary, guys. So make sure that you stop only here. So I'm showing you this formula because I'm going to use it. I find it easy for me to use it when we expand. So look, guys, oh, people say they cannot see. All right, I'll try to zoom next time, guys. Right, I'll try to zoom the question. But can you see the writing? Can you guys see the writing? So let me start with this. So our question is 3 minus, in fact, it's open bracket, 3 minus 2x, then close bracket to the power of 4. Guys, try to rearrange this so that you can get the correct answer. If you don't rearrange this, your expansion is going to start at the end of this expression. So you need to have at least 4 terms at the beginning of this expression. So when you expand, when you rewrite this, it's going to be negative 2x, right, plus 3. So what we did here, we just rewrote this. We made the first term here on the bracket to come here at the front, and then the last this one here, which is positive 3, to come at the end. I hope you guys can see that, right? So let's continue. Let's continue. Right, so when it's like this, guys, remember, when we expand here, we have x to the power of n. You need to recognize what is your x inside this bracket here, guys. So your x on that bracket, it's actually 2x. So you can name them like this, guys. You can say x, it's negative 2x, while your h, it's actually a 3. And then your n, which is the exponent, is 4. This is your x, by the way. Do you guys see it? And that is your h, and then that is your n. So when you rearrange them like this, it's easier for us to actually use the formula there. All right, so guys, let's continue. So let's look at the first term. The first term, it says x to the power of n. Now we know that our x in this case, it's actually negative 2x. This is where people get tricked, to be honest, guys. Look, they only put x, they forget that we also have negative 2 there. Do you guys see? So you must always put whatever x is there, which is negative 2x, put it all together, and then you put your n there. Remember our n, which is the power of 4. People tend to forget this, guys. So this was a trick that they were betting on for you not to get this question, guys, right? Now you continue, you do the second term. As you can see, the second term is this one here, where you have to multiply n with x to the power of n minus 1 multiplied by h. So our n, which is 4, right? Put it inside the bracket there. And then this time around, we have x, which is negative 2 multiplied by x to the power of n minus 1. Remember, this is our n. So n minus 1 is supposed to be 3. 4 minus 1. So that's it's going to give us 3. So we have the exponent there of 3. All right. So let's continue, guys. Guys, can't you see? I'll try to zoom, people, but I'm trying by all means to have a space, because when I keep on zooming, the space, guys, the space is the problem, right? I can see people say they cannot see, but try to make a full screen on your phone or your laptop, right? Try that, right? So let me continue. Where was I? Oh, I was here, guys, where I said this is that. Do you guys see? All right, now let's continue. Now look, we have h on the second term. Our h is what? It is 3. So you're gonna multiply by 3. There we go. Now we have first term, we have the second term. Now let's go to the third term. The third term, what do we have there? We have this, guys, right? There's our third term. So we have n, right? Our n, which is 4, multiplied by n minus 1. So our n minus 1, remember, is 4 minus 1. So that is going to give us 3 there. Do you guys see? Right. I hope you guys can see, because I'm trying to be as quick as possible so that we don't waste no time, and also we don't, our mic doesn't switch off. Right. So we're going to divide by 2 factorial. Right. So 2 factorial. Oh, this thing is acting up. We're going to divide by 2 factorial. Right. Just in case you don't know how to press the factorial, guys, because some people are struggling to press factorial. In your calculator, you must press shift, right? And then the next button is the button that has x to the power of negative 1. When you press shift first, then you press the button with x to the negative 1, your calculator is going to give you factorial there, right? I hope everyone is fine with that, because I'm having a challenge again with people understanding how to use their calculators. All right, but when it comes to Facebook and WhatsApp and Instagram, you guys wheeze when it comes to that. But anyway, enough about that. Let's continue, guys. Right, so let's look at the term here. Let's continue. As you can see, we have x to the power of n minus 2. So given that our x is negative 2x, right? Remember, our exponent here is n minus 2, right? There we go. This exponent here, it's n minus 2. So what is our n? Our n is 4 minus 2. So we must have the exponent of 2 there, guys, right? So let me just write it very quickly. So you're going to have the exponent of 2 there. And then we have h. See this h? Remember, our h is 3 there. So we're going to substitute with a 3. So let's do it. So it's going to be 3, but let's not forget this 3 is the power of 2. Guys, make sure that when you do this, you put them inside the brackets there. Because if you don't, some of the answers won't be correct, my good people, right? Won't be correct. So let's continue, right? Now we have the first term, second term, and we have the third term. Now it's time for us to do the fourth term. It looks long and tedious, but don't worry, guys, it's really nothing much. We first multiply by n. As you can see, our n is 4 there, right? And then we're gonna have to multiply by n minus 1. We know that n minus 1 is gonna give us 3. You guys see? All right, so you can multiply by 3 there. There we go. And then the last one here, we have n minus 2. What is n minus 2? It's actually 2. There we guys. Do you guys see? Right, let me just create more space. I'm gonna drag this to the side so that everyone can see. And if you look at our fourth term here, all this is divided by the third factorial, guys, right? I just showed people how to do the factorial. Third factorial, right? And then multiply by x to the power of n minus 3. Remember, our n it's actually 4, right? So it's on the other side actually, so you weren't able to see it, but if you can go back to the video, you will see that our n is 4. So how are we gonna write this? Our n is negative 2x, right, to the power of 4 minus 1. So this, I mean 4 minus 3, 4 minus 3 there. So our power there is going to be 1. Even if you don't write it, it's fine. And then the last part here, we have h to the power of 3. We know that our h here is actually a 3. So again, I need to create more space, guys, because if I zoom down, some of you won't see. So we're gonna have, what is our h is 3 to the power of a 3, right? So I will try to zoom down, guys. Can you see when I zoom down like this, especially the writing? Can you see the writing, guys? Can you see the writing before I continue here? Can you guys see the writing? Can you see the writing? Yes, no? Let me just do the equaling sign there. Right. Can you see the writing? I'm waiting for your response, guys. Yes. Okay. Yes. Okay. I'm seeing a lot of people are saying yes. All right. I am continuing, guys. So I continue. Now, inside your calculator, now you need to punch this now. You need to punch this part here. Let me just highlight it with black. This part here. Remember, you don't have x on your calculator, guys. Please don't make your life difficult. So what you should do is just put this negative 2 to the power of 4 inside your calculator, which is going to give you, what is negative 2 to the power of 4? I think it's going to give us 16. Oh, let me change the color. It's going to give us 16 there. And then obviously we have x to the power of 4, right? So this is going to be 16x to the power of 4. Now the first term is complete. Now let's go to the second term. Now look at the second term, guys. Let me highlight. We have 4 there. We also have this negative 3 to the, this negative 2 to the power of 3, and we also have this 3 there. So we have 3 numbers that are going to multiply each other. In your calculator, this is what you do, guys. 4, and then you multiply by negative 3 to the power, oh, multiply by negative 2, sorry guys, to the power of 3 multiplied by 3. This here, it will give you the numbers that you're supposed to get them, right? I think this is going to be minus, right? So if you do that, you will get negative 96, right? And then let's look at our x. Now as you can see, our x here, it has the power of 3, so this is going to be power of 3. Guys, do not forget h is 3 there, guys. All right, h is 3. Now let's go to the one that really needs you to pay attention, the third term. This is the third term. Let me just separate it very quickly. Now here's what you should do when you put this on your calculator. Remember, we have this 4, we have this 3, we have this negative 2 to the power of 2, and we have this 3 to the power of 2. All these are divided by 2 factorial. In your calculator, this is what you punch. You're going to punch 4, right? Multiply by 3, right? Multiply by negative 2 to the power of 2, multiply by 3 to the power of 2. All this is divided by 2 factorial, which is actually 6. 2 factorial, let me not put it this way. 2 factorial, by the way, guys, it's 6. If I'm not mistaken, let me just check. 2 factorial, it's oh sorry guys, 2 factorial is 2, right? 2 factorial is 2. So in your calculator, just put 2 factorial, and then this here, guys, is supposed to give you a positive answer, which is gonna be 201 216 x to the power of 2. Yes, I think that is the answer. Are we getting the same answer there, guys? Are we getting the same answer? Right. I hope we are getting the same answer. Don't just watch, guys. Try to solve these problems as well, so that we don't get wrong answers. Now we have the third term. Now the last term, which is the fourth term, they want us to also put all this, which is the which is the fourth term there. Again, we have 4 multiplied by 3 multiplied by 2 multiplied by -2. Remember, we exclude the x at the moment, and then multiply by 3 to the power of 3. So in your calculator, this is what you're going to do. 4 multiplied by 3 multiplied by 2, and then multiply by 3 to the power of 3. Divide by 3 factorial. Yes, 3 factorial is the one that is actually equaling to 6. So you put that on your calculator. You're going to have, I think the answer is going to be negative there. Let me just erase this very quickly, guys. The answer is going to be negative. So you're going to have the very same answer, which is 216. But let us not forget, our x here is not having the power of more than 1. So it's going to be just x. So guys, this here is our final answer. Remember, they wanted us to expand this expression to the fourth term. Now I'll show you the tricks if you didn't pay attention to those tricks, but I'll show you what were the tricks. First of all, the question was asked in this manner. They asked you in this manner. They say expand. What was it? It was yes, it was 3 minus 2x to the power of 4. So you needed to rearrange this, guys. You needed to rearrange this, because if you did it exactly from this, you're going to have 4 terms going backwards. So as you can see, this is the first term of the expression, that is the second term, and that is the third term, and this is the fourth term. So we're going to have 4 terms, by the way, going backwards, meaning you're going to start with the constant, and then you go with x to the power of whatever, and x to the power, and then you are going backwards, which is not a good idea, guys, right? So whenever you are given such a problem, try to rearrange in this manner where you can have x plus h to the power of n, right? Then from there, I think when you substitute your x to the power of n, which is this one here, you take everything, the coefficient, the sign, and everything, you put it there, and all of these, they get affected by the exponent there. I hope you guys are fine. Okay. Someone said I should repeat the last part. I think this is mahlohonolo. Mahlohonolo, you say I must repeat the last part. Which part is it? Are you talking about the fourth term? And also there's someone here who says I don't, should you include the power of x when you put in the calculator? There is no x in the calculator, I think. No, I think this is none. There's no x in the calculator. Whenever you include, let me just make an example with the fourth one. I think Mashono is also asking the same thing. Look, let me erase this very quickly before we move on, guys, right? Let me just erase this. I'm gonna use blue. Look, you have 4 there, right? We have 3, we have 2. You also have -2, the coefficient of x, and we have 3 to the power of 3. So these numbers are the ones that you can able to put or insert on your calculator. So what you do on your calculator, you say 4, okay, then you put it inside the brackets like that, multiply by 3, right? And then multiply by 2. And then here, when it comes to this one here, remember we have x. You don't include x because you don't have x on your calculator. You want to include only -2. Unfortunately, this one, it has the power of 1. But if it was the power of 3 or 5, you're going to put it there. And then the last one, which you have 3 to the power of 2. And all this is divided by 3 factorial, right? So you put this on the calculator, you're going to get this number here, which is -216, and then you multiply by x, since our x here has the power of 1. I hope everyone understood, guys. I hope everyone understood. So I am moving on, right? The formula, someone said, should we know the formula? Yes, you should know the formula. That formula doesn't appear for N4 on the formula sheet, so you should know it, guys. You should know it. It doesn't appear on your formula sheet, guys, unfortunately. All right. And then we have He didn't put the whole question in the calculator. I don't understand. The beer. Onayo, how can I put the calculator in the? They say on the fourth term I made a mistake. Oh, guys, did I make a mistake on the first? Can you double check on the fourth term, guys? Is it correct? My answer is incorrect. Ooh, where did we make a mistake, guys? If the answer is incorrect, if the answer is incorrect, where exactly did we make a mistake? We're 4 multiplied by 3 multiplied by 2 multiplied by -2, and then we have 3 multiplied by 3 to the power of 3 divided by 6. All right, people, the answer is correct, guys. I don't know who says the answer is incorrect. The answer is correct, people. Our fourth term is negative 216. It's negative 216x, right? It's correct. Double check your answer. There's no mistake. Say thank you, Vilagazi. Guys, double check the answers. Double check the answers before you say it's incorrect. Thank you, Kwaza. It says correct. Meaning I'm moving on to the next question, guys. Right? No mistake. Thank you, Felicia Lebu. Please make sure that you double check, guys. Right? Please make sure that you double check your work. There is no mistake. Thank you, guys. So shall I move to question 1.2? I mean, I'm erasing this, guys. If you didn't understand or you got lost somewhere, you can start the video at the beginning, you rewatch it again. I'm trying to be as quick as possible, guys, because the mic that I'm using here, it doesn't really last long. I need to get a new mic so that we can able to last longer when we do this, right? So I'm gonna zoom out so that you can see the question again. So we are done with question 1.1, which was binomial theorem. So let me zoom in so that you can see question 1.2. All right, can you guys see question 1. I'm gonna zoom it again. 1.2. So 1.2, this is our 1.2 here, guys. This is our 1.2. So 1.2, we are given this problem here. We have y, which is equaling to 1 over 4 sec 4x, right? And then they want us to differentiate with an aid of a function of the function rule. Now, guys, this is another way of saying use chain rule, guys, right? Chain rule. If you don't know the word function of a function, basically this means that it's a chain rule, guys, right? Now, I am going to copy this question and I'll write it where there is space so that we can able to do this rule here, right? So let me just zoom down again, right? Let me just create space very quickly. Let me write the question first. So the question, it goes like this. It's y is equaling to 1 over 4 sec, right, 4x. There we go. So let me just create a space, guys. Right. There we go, guys. Let's create a space. Right, so let's look at the problem that we have here. Now, they want us to use chain rule or function of a function when we integrate, when we differentiate this one, guys. So I almost said integration. When we differentiate this one, they want us to use the chain rule. Now, the chain rule is very simple. You need to find the outer function and the inner function. Now, for this one, guys, for this one, I'm going to highlight the whole thing, guys, is the outer function, right? And then the 4x there, you can take it as your inner function, right? So if you decide to do it this way, obviously it has different ways of solving this one, but I prefer to take the 4x as our as our inner function. So you can equate the 4x with u. So you can say u is equaling to 4x, right? Now, when it comes to y, you're no longer equating 1 over 4 sec with 4x there. It's going to be 1 over sec with u, right? Let me try to explain this a little bit further, guys, right? Let me try to explain this a little bit further. Remember, u is 4x. So 4x, it is there, guys, right? So meaning instead of inserting 4x there, we're going to insert u, right? I hope everyone can understand. So it's just a substitution method, people, right? It's just a substitution method, right? So the chain rule requires you guys to derive these two. So you have to derive this one, u. So this is the standard derivative, guys. When you derive the standard derivative, it's going to be du over dx. Remember, we are deriving with respect to u. That's why we have du over dx there. And then this is going to give us just 4, right? Very simple, straightforward. It is a standard derivative. If you don't know how this came about, basically it's x and then 1 minus 1. Anything to the power of 0, we're going to have x to the power of 0. Anything to the power of 0, it's 1, guys, right? So I assume most people know this, so I'm not going to go on with this one like that. Now let's continue with with the second derivative, guys. Let's continue with the second derivative of y. So let's look at y, right? So we have dy over du. As we are differentiating with respect to u, that's why we have du. Here we have dx because we are doing with respect to x. There we have du with respect to u, right? So do not forget that one as well. Those are the things that you should pay attention to, right? So let's continue. Now, what is the differentiation of sec? Now, this one, guys, is there on your formula sheet. I hope you guys have your formula sheet with you. If you don't, please make sure that whenever we do the live stream, mostly have the formula sheet with you. But the integral of our sec, let us not forget we have a coefficient which is 1 over 4. We're going to keep it. And then we're going to multiply by the integral of sec, which is going to be sec u multiplied by tan u, right? Let me just write u there. You guys see them? There we go. So these are the differentiation of u and y. I hope I said differentiation. The differentiation of sec, guys, it's sec u tan u multiplied by the coefficient, by the way, right? So let's continue, guys. Let's continue. Are we still together, people? Are we still together? Please make sure that you remind me or you stop me if you cannot hear me anymore, guys, right? But if you can hear me, then we are moving on, right? So when you continue from here, the chain rule states that you must differentiate over dy over dx is actually the multiplication of du over dx, right? So and dy over du. So when you multiply the differentiation of du of u and the differentiation of y, they're gonna give you dy over dx, guys, right? So let's look at du over d. Let me do this. Let's look at du over dx. This is our du over dx, which is equaling to 4, right? We need to multiply this 4 with the differentiation of y, which is dy over du. So basically that is the formula that we're going to use. So let me just create the space here. Let me just create a space. Also, I'm going to zoom down a bit so that you can see everything. Right. There we go. So let's do it. So if we continue, let me just use the red, dy over dx. Our du over dx, remember, guys, it's 4. So you're going to write 4 there. Multiply by dy over du, which is going to be 1 over 4 sec u multiplied by tan u. Remember, you can find this on your formula sheet, guys. So it's 1 over 4, right, sec u multiplied by tan u, right? Look, we have 4 and 4, they divide each other. You'll be left with 1 there. So your final answer, let me just continue here on the side. It's going to be sec, right? But instead of writing this u here, we're just gonna resubstitute again. Remember, u is equaling to 4x, so you're just gonna write 4x multiplied by tan 4x. That is your final answer, and this is how you guys use the, what is this, the chain rule, guys. Okay, this is where you use the chain rule. All right, someone said the mic is starting to lose, what is this, some signal. Oh, guys, sometimes it's the network, right? But the mic is still fine, guys, don't worry. I can see it as well. The mic is still fine. We should get worried on the on our last question, for this question one, but so far it's still fine, guys. We are done with 1.2. So this is another way of doing it. Some people can do it this way. Let me just do the alternative on the side. Some can decide to say u is equaling to sec 4x. This is an alternative, guys, right? This is an alternative. If you decide to do this, then your y is going to be equaling to 1 over 4 multiplied by u. Then you differentiate this. If you differentiate u, it's going to be du over dx, which is going to give us sec u, sec u multiplied by tan u. There we go. Then if you differentiate y, it's going to give you, look, you are differentiating y with respect to u. Do you guys see? This is similar to 1 over 4 multiplied by x. If I say differentiate 1 over 4 multiplied by x, this is going to give us 1 over 4. 1 over 4, because this here is the power of 1, right? So just in case you don't understand that one, right? So if you decide to use this method here, or if you decide to label them like this, then your integral or your differentiation for y is going to be, oh, by the way, this is not dx, guys, this is du, by the way, it's du. So if you decide to differentiate this one in this manner, so it's gonna be 1 over 4, because the u, it's having the power of 1 there. Then as you can see, look at this, it's the same there, it's the same there, but the difference there is that this one is the 1 over 4, while the other only has 4. So it's just gonna multiply. Let me just continue on the side, guys. Let me just continue on the side. So if you continue here, remember dy over dx, you must multiply du over dx with dy over du, right? So when we look at our du over dx, this one here, it's what? It's gonna be sec u multiplied by tan u, right? And then remember, we must multiply by dy over du. Our dy over du, it's only 1 over 4, right? So 1 over 4, you can see, multiplied by 1 over 4, right? There is 4 missing here, guys. Where is our 4? Oh god, oh god, yes, I made a mistake here, guys. Do you guys see? Oh, I made a mistake here. Can I go back? Can I go back? Can I go back? Can I go back? I think I made a mistake here. Oh, I'm in a rush, guys. I must take it slowly. I made a mistake here, guys. Oh, I made a mistake here. Remember, if you differentiate this, it's gonna be 4. I forgot that you must multiply by the n there, guys. Then it's gonna be 4, then sec u, and then tan u. Are we together now? I think some people, they saw the mistake. If you saw the mistake, I hope you managed to rectify it as well, name, while you are busy working them. Yes, sec 4x, when you differentiate it, this 4 here is going to multiply there, guys, right? Because the 4, it's also the what is this, it's also, Jesus, man, guys, I'm making a lot of mistakes again here. The 4 here is going to be is part of the differentiation. Yes, remember, we are equating this to u. There we go. This is correct now. As for this one here, is fine like this. This one is the one that kind of gave us the question, the problem. Yes, when you differentiate sec 4x, the answer is going to be 4 sec 4x multiplied by tan 4x. Then you multiply the two, guys, right? There we go. Du over dx, which is going to be 4. Now this is correct. Sec 4x multiply by what is our tan? It's going to be tan for x. There we go. Multiply by 1 over 4. 1 over 4 is dy is dy over du, which is this one here. Then obviously this, they're going to divide each other, and you left with sec for x multiplied by tan for x. There we go, guys. This is another way of doing this. I hope you guys didn't get confused, because somehow I made a mistake there. So I hope you didn't get confused there on that one, guys. All right. I hope we are fine, people. We are done with 1.2. I'm gonna move to 1.3. So someone asked there, please share that paper and memo after the section. Oh, all right, it's fine. I'm gonna try to send it on the group, guys. Remember, at the beginning of this video, there is a channel for WhatsApp. I cannot send it here on YouTube, so I will send it there on the channel. Join that channel. I'll send it as a file that needs you to download. So I'm erasing this, guys. I hope everyone is fine here with the change rule and everything. Guys, I've made videos on these things, by the way. You can navigate these sections on this channel on a playlist section there. You can go to playlist. You will see I've made videos on chain rule. I made videos on product rule. I also made videos on binomial theorem. But those videos, it was the beginning of the channel, so the audio there is not as good as the one that we have at the moment, right? So we are done with this one. Let me just zoom in and let's look at 1.3. Right, I'm gonna zoom in. Let's do 1.3. Okay, right. Where can you join the WhatsApp group? At the beginning of the video that you're watching at the moment, there is a QR code there. I put it there. You just have to scan it. It will take you straight to the WhatsApp channel, guys, right? So I don't know how you're gonna do this, but you're gonna scan it. You can ask a friend to view the video, then you scan via that video, right? And then you'll be part of the group. But if there is someone you know who's part of the group, it can also send you the link, guys, right? So let's look at 1.3. 1.3. Oh, let me just zoom down a bit. But before I do that, let me just read some comments there. Right. Yeah, people are asking how to join the group, guys. Go to the beginning of the what is this? The beginning of the all right, here's what I'm going to do, guys. I'm gonna leave the link on the comment section, the after live comment section, because here on live, if I post here, it's gonna be is gonna move up. It keeps on moving because people are commenting. So after the after the live stream, I'm gonna leave the link on the comment section. I'm gonna pin it, so you have to come back when we are done, and then you'll see that link. But at the beginning of the video, again, I said to you guys, there is a link there. There is a QR code. You have to scan it. You have to scan it. So let's look at 1.3, guys. 1.3, I hope you can see it. They want us here to differentiate with respect to x, right? If you are given this problem there, so they say y is equaling to 2 log x minus tan 2x minus 3r to the power of 2x plus x to the power of negative 2 minus 3 minus 2x, or minus 3 to the power of negative 2x plus 9x plus 6. So this is 7 marks, guys, right? So let me just erase this very quickly. Let me try to copy this question very quickly, guys, right? So far, are we still together, people? I'll try to copy it very quickly. Let me just zoom down a bit so that everyone can see. Okay, this zooming down is fine. Now we have the following. Let me try to write it very quickly. We have y is equaling to, I think it's 2 log, right, x. right? Minus tan 2x, right? Minus 3r to the power of negative 2x, and then plus x to the power of negative 2, and then we have minus 3 and to the power of negative 2x plus 9x plus 6, right? Let me double check it if we are having the right thing. Just gonna zoom out a bit so that I can see the right thing. Right, let's see. We have, there we go. Right. Oh, we don't have minus here, guys. Oh, I almost made a mistake there. We don't have minus there. It's positive. There we go. So this is gonna be positive. Yes, and then we have minus x to the power of minus 2 and minus 3. All right, everything is fine, people. Everything I copied correctly. So let's do it. Okay, people, I hope you are paying attention. So let's look at this. I'm gonna use red color there, guys. Right, so we have these terms that you see here. Let's let we have these terms that we have here, guys. So the first thing that you must do here, guys, is to recognize what differentiation or the derivative that you need to use here. If you don't know what derivative you must use here, you will struggle to solve this one. Let's start with the first term. As you can see, the first term we have to use the log derivative, right? So the second term we have to use the trigonometric ratio, which is tan in this case. You're going to find it on the formula sheet. The third term, well, most people, they get confused here. As you can see, we have x as an exponent. Once x it becomes an exponent, just know that it is an exponential derivative, right? Right. And then we have this one here. What term is this? The fourth term, where we have x to the power of negative 2. This is the standard derivative, guys, right? And then we have the fifth one, where we also have x as an exponent there. Basically, this means that it's our exponential derivative. And then we have plus 9x, which means it's a standard, and we have 6. Also, this is the standard. So you need to know the derivative of each term here. So lucky enough, these terms here, they don't need to be simplified. We can jump straight into our derivative. So first of all, dy over dx. So we need to do this one. Guys, I'm gonna show you the general formula. When you derive, let me just do this, right? When you derive log, guys, you're gonna be given log, right? K, which is a coefficient, by the way, right? To the it has the base of, let's say the base it's a, then we have x there, right? When you derive this dy over dx, right? Oh, we have n there, guys, right? We have n. When you derive this, guys, here's what you do. The k there is a coefficient, you multiply by it. In fact, you're going to multiply by the exponent of x. If we had an exponent, you're going to multiply by exponent of x, and then with a k there, and then we divide. Now you're gonna have x there divided, multiplied by natural log or ln, and then the base, which is our a there. So you must be able to recognize what is your k, what is your base, what is your n there. So let's look at our question then. As you can see, our k here is 2, our n is 1. Our base, guys, whenever you have log that does not have a base like this, let's say log 2, right? Basically, this log here, it has the base of 10. If the base is not written, we know that the base is 10. I hope you are following each other. So let's use that formula. The formula says the derivative of log is going to be n multiplied by k. So our n is 1 there, and then our k is 2. So it's going to be 2 multiplied by 1. That is going to give us that. Divide by, right? And then multiply by, or divide by x multiplied by natural log base. So x is gonna be here, and natural log, then our base. Remember, we said we don't have no base here, so this is gonna give us 10. Are we still together, people? Are we still together? right? So you are done with the first one. Now let's look at the second term. We have minus there, right? So the second term we have negative tan 2x, right? So look, any trigonometric ratio, guys, when you integrate, when you differentiate it, by the way, not integrate, by the way, when you differentiate it, it's gonna give you, first of all, you're gonna have k, the coefficient of tan, right, multiplied by tan, right, and then we have n multiplied by x, the coefficient of x. It's always there. So in your formula sheet, they don't show these coefficients, guys, right? So when you differentiate this, you're gonna multiply n with k, because these coefficients, they're gonna multiply each other. Then you write the derivative of tan. In this case now, the derivative of tan is sec squared n x, right? Unfortunately, on your formula sheet, they don't show this coefficient, guys, right? So whenever you derive, you always multiply by the coefficient. You will see, if you were watching the chain rule that we did then, our sec had 2x. This is what I forgot, guys. It's easy to forget it, by the way. This n here is very, very simple to forget it. Make sure you don't forget it. Even here, don't forget it there as well. All right. So when we differentiate this, it's going to give us 2, right? Because we do not have what's happening here, guys, right? Gonna give us 2. Our k is the coefficient of tan, so our k there is 1. Even though we don't write it, it's gonna be 2 multiplied by 1, k multiplied by n, as you can see, and then you write the differentiation of tan, which is sec squared 2x. Right, now we move on. Now let's go to this term here. This is a term where most people, they will get confused. I'll try to explain to you guys the best that I can. Are we still together, people? Are we still together? Right. Now, let me show you guys what I mean by this. This already, it's a exponential because our x is an exponent. So when you differentiate exponential functions or exponential problems, this is what you do. You will be given in this manner. You have k, right, multiplied by a, our base, and then we have n, the coefficient of x, like that, right? So when you differentiate this, you will have to multiply by n, the coefficient of x, multiply by k, and then you write it as it is. You're gonna have base multiplied by, or base to the power of n x, then natural log, then base, right? This is how you differentiate an exponential expression when it comes to differentiation. Now you need to identify your n, your k, your a, and yeah, that's it. Only these 3 things on the question then. If you can look at this, guys, your base, remember, is the number that has the power of x then. If you can see this, we have 3 and r is the one that has the power of 2x. 3 is just 3 to the power of 1. You guys see? So when you differentiate this, here's what you do. It's going to be minus. Obviously, we have the minus there. Now, this 3 represents k, right? And then this 2 represents n, right? And then this r represents a, right? So you must be able to tell what is what there in order for you to substitute on this formula there. So like I said, 3 represent k, so it's going to be k, right? The k there. And then 2 represent n multiplied by 2, right? But then the base is what on this question here, it's actually r, right? So we have the power of 2x, so we're still fine. But then let's not forget we multiply by natural log or ln r. Instead of putting anything else, remember a, it's r there, guys. Remember we put our base there. Most people, they get confused here. I hope you did not get confused, guys. Yeah, I hope you did not get confused, but I'll try by all means to explain it again when we get to this one here. Right, so we are done with that one. Now it's time for us to do the standard differentiation, right? Look at this one here, guys. It's x to the power of -2, guys. The x is the base. Whenever the x is the base, guys, it's when we use the standard differentiation, right? I hope everyone is with us there. I will try to be as slow as I can be to do this one. Now, the standard differentiation, we know that it's x to the power of n, right? And then when we differentiate dy over dx, it's going to be multiplied by nx n to the power, x and x to the power of n minus 1, right? So look, if we apply this, this is our n. You guys see -2 there, it's our n. So we must multiply by -2. There we go. And we have x, and then we have -2, right? Oh, where am I? Oh, this one here, guys, right? Not that one. Oh, I almost made it. This one here, guys, this one here, it's our power, right? -2, so we multiply by it there, guys. -2, right, multiplied by x to the power of -2 plus 1, because we, oh, it's plus, oh guys, oh, minus, guys. I almost mixed this with integration. Be very careful, guys. Integration and differentiation, they're almost the same. Be very careful, right? -1, we follow this formula here, right? So I need more space. I'm gonna erase this part then, right? Are we still together, people? Are we still together? Are we still together? Make sure that you are with us, right? So we are done with this one. It's time for us to do this one. This one again is an exponential, guys, right? So we have minus there, minus, and then what do we have there? We have 3 to the power of -2x. Like I said, when x is an exponent, you must use exponential. So like I said, the standard equation, it's k multiplied by the base, the n as an exponent, which is also the coefficient of x. When you differentiate there, this is going to be what is it? It's gonna be n multiplied by k multiplied by the base to the power of nx multiplied by natural log base, right? Again, identify here, identify your k, your n, and also your a, right, which is the base. If I look at this, our k here, which is a coefficient of 3, it's 1. Our 3 is the base because it has the power of -2x there, and then -2, it's our coefficient of x, which is n. So when you use this formula to substitute them, it's going to be n multiplied by k. So our n, which is going to be -2, the coefficient of x, k there, which is the coefficient of the base, which is 3, it's 1. So even if you don't write it, it's fine. And then multiply by a. Our a there, which is the base, is going to be 3 to the power of, let me just do this. Let me remove the bracket. It's going to be 3 to the power of -2x. And then natural log, then we put the base, which is our a. Our a there is what? 3 there. I hope you managed to understand it this time around, people, because I've done it twice, right? I've done it twice on this one here, and that one there, right? So I hope you managed to understand it, right? So let's continue. Now we do this one. This is a standard differentiation, so this is going to give us +9. And then the last one there, which is a constant, when you differentiate, guys, it's going to give us 0, right? So I hope everyone managed to understand this, so you can simplify it further, so that your work can be neat, right? So the first term is going to be 2x, 2 divided by x ln 10. And then the second term, there's nothing we can do here, it's fine, it's 2 sec squared 2x, right? And then look at this, we have 3 multiplied by 2, this is going to give us -6, right? And then we have r 2x ln r there, right? And then let's look at this, we have this -2, so this is going to give us -2 x to the power of -3, right? We have -2 and -1 there. Do you guys see? They are subtracting each other. In a way, they're kind of adding each other. So it's going to give us that there. And then we have this negative multiplied by that -2. This is going to give us +2, right? And then multiply by 3 to the power of -2x ln 3 plus 9. plus 0. Always include the 0, guys. Sometimes the 0 is the mark, so they can mark you for 0, guys. All right, so before we continue, I would like to highlight this one a lot, guys. I'm always highlighting this one. People make mistakes here. Remember, you cannot multiply this 2 with this 3 there. The 2 is a coefficient, and then the 3 is the base because it has the power of 2, negative 2x there, while the negative 2 has the power of 1 there. So that's why I left them like this. I hope you guys understood. Do we have anyone who did not understand? So this is our answer here, guys. This is our answer. Sometimes this one here, they might want you, not that one. Sometimes this one here, they might want you to leave it like this: negative 2 to the power of x to the negative 2 divided by x to the power of 3. Yes, they might want you to leave it like this sometimes, guys, right? But I would say leave it like that to make your life easier. Are we still together, people? Are we still fine? Are we still understanding our differentiation? Right, I am gonna erase here. If you don't have any questions, if you all understand, then we are fine. We are all good. Do we understand? Okay, let me erase this. So this was 7 marks, people. Guys, are we fine? Are we understanding? It's quiet now. I would really appreciate it if you guys say something so that I can see that I'm not speaking to myself. Right. Are we okay? Are we not okay? Did we understand differentiation of this one? Because these are polynomials when it comes to differentiation. Yes, we do understand. Thank you, Mlambo. Thank you, Lebu, Felicia. Thank you, Cash Out 144. Pumzile Zulu. Okay, 3 people say they understand. I assume others they cannot comment, so it's fine. It's fine. Yes, understand, sir. Thank you very much, guys, for commenting. So I'm erasing this. If everyone understood, then I'm erasing this. Again, people, if you want to join the group on WhatsApp, I will leave the link on the comment section after the live, though. Right, so what I'm going to what you can do at the moment, if you really want to join it now, you can go at the beginning of this video. I left the QR code there. You scan on that code, it will take you straight to the group, or to the WhatsApp channel. All right, people, so we're gonna do number 1.4. This is a bit long, guys. I hope our mic is still fine. So I'm gonna try to be as quick as possible before our mic switches off. So let's look at 1.4. Now 1.4, we are given this trinomial here, right? So in fact, this is not a trinomial. Nope. This is having x to the power of 5, so of 3, in fact, x to the power of 3. So this is more like a cubic graph, right? But we are not required to draw the graph. So what is given to us here is y is equaling to 2x to the power of 3 minus 5x squared plus 4x plus 3, right? So 4.1.1, they want us to use differentiation to find the coordinates of the maximum and the minimum turning point, right? So 4.1.2, they want us to find the coordinates of point of inflation. So we're gonna do all these on the side. So I'm gonna copy this question very quickly so that we can able to do this. Someone said that can I do another example? At the moment I can't, Mashaba, but I have already done videos on polynomials, differentiating polynomials. Again, on this channel, you can just go to playlist and maneuver around the playlist section there. You will see polynomial derivatives there. But you're also gonna see how I named them. So go there, you'll see lots and lot of examples similar to that one. So at the moment I cannot because of the mic, but if the mic was fine, we're going to do it again and again until you understand, Mashaba. But for now, let's just do this question here. So this question says we have y is equaling to 2x to the power of 3, right, minus 5x to the power of 2 plus 4x plus 3. So they want us to find maximum and minimum turning points, guys, right? So the first step that you must do here is to derive the original equation. So we're going to derive it and equate it to 0. So we can say dx, dy over dx is equaling to 0. So let's derive it. So the first term here, all of these, by the way, are standard derivative, guys. So the first term is going to be 2 multiplied by 3 is going to give us 6x squared. And then the second term, we have negative 5 multiplied by 2 is going to give us negative 10x, and then plus 4. All this is equaling to 0, guys. So from here, so we can rewrite it this way, or the best thing that you can do is to divide by the common factor. As you can see, we have a common factor here, which is 2. So let's divide by 2 throughout. Dividing by 2 throughout here, let's divide by 2. So if you divide by 2, I'm going to start with this one here. We're going to have, what is 6 divided by 2? This is going to give us 3x squared, and then minus, what is 10 divided by 2? This is going to give us 5x. And then what is 4 divided by 2? That is going to give us 2. All this is equaling to 0. Guys, when you divide by 2 like this, anything dividing 0, it's 0, guys, right? So this is still the same equation there. We just simplify it further. Now, when it's like this, we can solve for x. So if we solve for x, we need to factorize them. Let's factorize. Now, if this factorization in this manner, it's quite a challenge for you, you can use the formula, guys, all right? You can use the formula. Remember this formula here. You can use it just in case you are not able to factorize. I think it's 2a like that, right? Yes, you can use this formula. Just substitute. Remember, this is your, let me just highlight them very quickly. If you want to use the formula, this is your a, this is your b, and that is your c. All right, so the coefficient of x squared, it's a. The coefficient of x is b, and the coefficient of, or the constant, is c. Right, so let's look at this. The first term here, we have 3x squared. We can put 3x here, and then we put x there. If you multiply 3x and x, you will get you will get positive 3x squared, right? So this is fine. These are the factors for 3x squared. But then we need to find the factors of 2 that when you multiply with these, they're going to give us numbers that when they add, they're going to give you negative 5. So the factors of 2 is 2 and 1, right? So you have to be careful. So if I can put 2 here, right, and put 1 there, right? Let me see. If I say 3 multiplied by 1, this is going to give us 3x. You guys see? And then if I do the following, if I say 2 multiplied by 3 multiplied by x, this is going to give us how many x's? We're going to have 2x, right? Then if they are minus like that, they're going to give us negative 5, right? But guys, if you can't do this, please do not use this method. It's really need someone who understands how to factorize to the core, right? So let me just continue here, guys. Let me just continue, right? So meaning if we have look, we have minus and plus. It means inside our brackets we have minus minus, so this is going to be minus, and that is also going to be minus, right? To double check, you can multiply here, remove the bracket, it should take us back there, right? So we can say this here, 3x is equaling to positive 2 because we transpose 2 to the other side, and the other one, x is equaling to 1. But this one here, we need to simplify it. We divide by 3. We also divide by 3 there. So you're going to have x is equaling to 2 over 3. So we have our x values. Now we need to find our y values. As you can see, our x values, we have 1 and 2 over 3. 2 over 3, I think, is the same as 0.667, right? All right, can you hear me now? I just charged the mic for few minutes. Can you hear me? Can you hear me? Yes? No? Just charge the mic, guys, so that we can finish this part. Can you hear me? Can you hear me now? All right, I think you can hear me. All right, so I'm gonna erase this part because this mic, when it's off, I can't pay attention. I'm gonna start here, guys. Oh no, let me go back. I'm gonna erase this part here. This part here. Yeah, I think it went off here. All right, people, let's continue. Remember, this is our original equation. In order for us to get the y values, we need to substitute the x value. So we have two x values there. So we can say when x is 1, right? We substitute x wherever we substitute 1 wherever there is x. So we can say 2. We have x to the power of 3 is going to be 1 to the power of 3 minus 5, and then we substitute 1 there is going to be 1 to the power of 2 because we have x to the power of 2 there, and then we say plus 4x. Instead of writing 4x, we write 4 multiplied by 1 plus 3 there, people, right? Plus 3. So let's put this on a calculator. If you put this on a calculator, this is gonna give us let me put it on my calculator. You can also put it in your calculator, guys. Let's see what you're going to get there. Right, I am getting 4. Are you guys getting 4? Right, I hope you got 4, guys. You correct me if it's not correct, but make sure before you correct me you put the right information there. So we can say 10.1, right? When x is 1, and then our y is gonna give us 4 there. Right, now let's do it when x is equaling to 2 over 3. Remember this one here, or 0.667. There we go. So let's do it. So when if you put our x there wherever there is y, remember we're gonna take this formula again and substitute. So we can say y is equaling to 2, then we're going to write 2 divided by 3 to the power of 3 minus 5, right? And then we have 2 divided by 3 to the power of 2 minus, or plus this time around, plus 4. And then we have 2 divided by 3, and then we have plus 3. Remember, guys, we just substitute the x values wherever there is x there, guys, right? This x value here for this one. So if you put this on a calculator, let's put it on a calculator very quickly. I'm gonna try to be as quick as possible, guys. What I'm getting here, it's 4,037, right? Okay, you might get some fraction. I think the fraction is 109 divided by 27. If it's like this, it's too much, guys. Just leave it as a decimal like that, and also leave it to 3 decimal. So you can say 10.2, right? 10.2. We know that when x is 2 over 3, our y is 4,037, and then those are your turning points, as you can see, people. Now what you need to understand here is you need to know which one is maximum, which one is minimum. Oh, can we write, someone ask a question, guys. Let me answer the question. It's Mashava said, can we write TP2 in decimal? Yes, you can, as long as it's correct, guys. As long as it's correct, you can. Right? Right, let's continue. Right. The mic is still fine. Someone said they cannot hear. I think they are watching from they are behind, they're not watching live, or it's delaying. But anyway, people, we fixed the mic. Let's continue. Hopefully it won't keep quiet as well. Let's continue, people. Right, now how do we distinguish between the maximum turning point and the minimum turning point? We have what we call the checking method, guys, right? So when you check, let me just write check there. When you check, guys, you need to differentiate our original equation twice, right? You need to differentiate it twice. So the first derivative, if you still remember, it was dy over dx, which is equaling to the mic is on, guys. I'm gonna start over here again, guys. Yeah, the mic is bad. So meaning when I'm done with this question 4.1, I am going to charge the mic a bit, guys, name, and then you guys ask questions. I'll try to answer them, right? So I think the mic went on when I was about to explain the checking part. Remember, you need to know which of these two turning points are it's maximum and minimum. So we're gonna use the checking method. So when we check here, guys, okay, when you check, you have to derive the second time. Oh, I made a mistake here. Let me just yes. When you check, you have to derive the second time. So for the first time, when we derive this equation there, it gave us this. And then for the second time, when we derive, guys, when we derive dy over dx squared there. Let me remove the square there. It's actually d squared, not y. So this is gonna be like this, right? So when you do the second derivative, obviously this is gonna give us 12, the first term, and the second term is gonna be 10, right? So when we check, we have to substitute. Let me just use this color. We have to substitute the x values, these values here, on this equation there, right? And this is not equaling to 0, by the way. So we have to substitute those x values. So if the x value that we substituted here give us the final answer, which is negative, just know that is going to be maximum turning point. And if the x values give us the answer which is positive, just know that is the minimum turning point. So let me create a little bit of space again so that we can check. Right, so let's do it. So let's do it. Let's use this color. So when we check it here, guys, we're gonna have uh when you check there, let's say when x is equaling to 1, when you check there, we're gonna have the following. There we go. Now we have 12. Instead of writing x, we're gonna put 1 there minus 10. If you put this on a calculator, this is gonna give us 2. So meaning the turning point that has x as 1, this one here, is gonna be our minimum, because whenever this is positive, just know the turning point is gonna be minimum. Then when x is 2 over 3, we're gonna do the very same thing here. Let me just do it here on the side. D squared over d squared y over dx squared. Now we're gonna do the very same thing. It's gonna be 12. Instead of writing x this time around, we're gonna use this one here, which is gonna be 2 over 3 and then minus 10. Now here, this one is gonna give us what? I think it's gonna give us negative 2 as well. Right. So meaning, because we use this turning point here, this one there, to substitute the x value. So if it give us negative, this become maximum. So this turning point here, it's maximum. There we go, guys. You guys see? So this is how you do it when you do the checking, guys. Right? This is how you do it when you do the checking. I hope you guys can see and understand the checking part. So we're gonna do the point of inflection, which is very, very simple. For now, let me just erase the space here. But before I erase, do we have any questions? Do we have any questions concerning the turning point, guys? Do we have any question concerning the turning point? Let me just zoom down here, guys. Any question concerning the turning point and the distinguishing between the maximum, the turning points, guys? Before the mic go off, before the mic goes off, any questions? Uh, can we go? No questions. Cash out 144. Okay. Says no. Any question, guys? Any questions? Yes. No. Destiny Sali. Okay. No. Kit the dope. We are good. Nah. All right. People are saying we are fine. We are good, sir. All right, people. If you don't have questions, then I'm gonna erase this. While I'm erasing, I'm gonna switch off the mic and charge it for a minute so that whenever we do 4.1.2, we have enough power, because I don't like this thing of ours um switching off. Right, we have Lewi Felicia says we shall redo the factorization again. Okay, you know what, Label? Can we do it after we have charged here, guys? Right? Can we do it? All right, let me erase this, then we're gonna do it later on. Who's this Label? Right, remind me when we are done, Label, on the comment. When we are done, please remind me again on that question of factorization, because it's long and might need me to explain certain things that it will take time. Right, so I'm erasing this, guys. All right, people, we are back. Now let's look at point of inflation, guys, which is 1.4.2. But before I do that, I think we have princess. If we substitute x on the second derivative, we put in we put it in fraction. Yeah, it's up to you guys. You can put it in fraction, you can put it as decimals, but make sure that you only substitute the x values when you check. And remember, your second derivative, if it's positive, just know that it's a minimum turning point, and when it's negative, it's a maximum turning point. You just write minimum maximum next to your coordinates. Do not forget to write that, guys. It's very, very important. All right, so let's do the point of inflation. Now, another information that you need to know about the point of inflation is as follow. Point of inflation, first of all, you must derive your equation second time this time around, right? But this second derivative must be equaling to 0. Guys, do not confuse the point of inflation with the checking. Remember, when we check, we derive it twice, but it is not equaling to 0. And also there, we substitute with x value. Now, when we are seeking for the point of inflation, we derive twice and then we equate everything to 0. So if you still remember, our second derivative, it was let me just write here, it was 12 x minus 10, but it's going to be equaling to 0, guys, right? So when it's like this, we need to find the x value. So you're going to transpose 10 to the other side. You're going to have 12x, which is equaling to 10, divide by 12. You guys see? So when you divide by 12, we're going to have x, and then this here is going to give us 5 over 6. This is our x value, remember that. But when you're looking for the y value, always guys, always, whenever you're looking for the y value, you substitute the x value to the original, right? So I'm gonna do it here so that we don't get confused. Let me just create a little bit of space because I wanted to do it somewhere else, but I can see that we might get confused, right? So let me just do it next to this one here. So wherever there is x, we're going to substitute with this x value there. We have 2, right? And then we're going to have 5 over 6 to the power of 3 minus 5. And then we're going to have 5 over 6 to the power of 2 plus 4. And then wherever there is x is 5 over 6. And then we have plus 3. If you put all this on your calculator, you must be able to get your y value. Now, our y value here, if I still remember, guys, let me just put it on a calculator very quickly, right? Let me just put it on a calculator. Also, put it on a calculator and check if your answer is correct, right? Always put it on a calculator as well. Put it on a calculator, right? My answer here is gonna be 4,019. There we go. So this is our y. So your point of inflation, let me just write here, point of inflation. Don't write everything, guys. You can write it like this. When x is 5 over 6, right, your y is 4,019. There we go. So there, guys, is your point of inflation. So we are done with 1.4. 1.4, it's a bit long, guys. I hope you managed to understand it, people, because this year it was because of the mic and everything. I'm worried that some of you got lost somewhere there. But guys, I hope you managed to understand. Some people already they got the answer, which is 4.19. Yes, that is our y value there. So this is also 4 marks as well. guys. Our mic is bad. Hadem. Our mic is, I know guys, I know our mic is super bad, but I assume everyone managed to understand this question here, which was the point of inflation, by the way, guys, right? I assume everyone managed to understand. So let me try to do this one here, which is 1.5. They want us to find the limit of the following problem here. So let's hope we're gonna be quick enough before our mic fails on us, because this mic, people, this mic is killing us. This mic is killing us, people. If you have questions, please hold on to your questions. When we are finished here, we will try. I will try to charge this so that I can answer your questions, because the more I answer the questions, the more the mic switches off. Okay, so I'm gonna write it here. So we have the limit. We have the limit. Okay, this is too close there. All right, we have the limit there, guys. Yeah, let's do this. Right, so we have the limit. Right, limit. We have x squared minus 4 divided by 3x minus 6, and then that's it, people, right? That's it. Yes, we are back, man. The mic is super bad. Right, so they say x is approaching, what is it approaching? 2. Yes, our x is approaching 2. Now this one here, guys, there are three methods that you must apply. The first method is direct substitution. So direct substitution, basically, since x is approaching 2, wherever there is x, we put 2. So if you do direct substitution, you can see that it's going to be 2 to the power of 2 minus 4 divided by 3 multiplied by 2 minus 6. This here, guys, is going to give us 0 divided by 0. When it's like this, the first method of direct substitution, we're not gonna use it. We need to use the other method. Remember, if you have infinity or 0 as an answer, especially when you divide 0 with 0, just know that direct substitution, it is not applicable. Now you need to do the second method. The second method is to simplify before you do any any substitution. So if you look at the numerator there, we have limit. The numerator is a difference of two squares, guys. It's x minus 2 and x plus 2, right? And then on the denominator, we also can simplify it further. We take out the common factor, which is 3 there. We'll be left with x minus 2. Oh, I made a mistake, 2. Right, x minus 2. Right, because if you say 3 multiplied by 2 is going to give us this negative 6 there. So if you can see this, okay, x approaches 2. So if you can see, we have negative, we have 2 minus, we have x minus 2 and another x minus 2. So we basically left with limits x approaches 2, x approaches 2, and then we have x plus 2. The mic is about to switch off, guys, so I'm gonna be quick. So now you start substituting. When you substitute, wherever there is x, you substitute by 2 plus 2 divided by 3. So our final answer is gonna be 4 divided by 3. There we go, people. This is our final answer for 1.5. Okay, we are done with this question, guys. We're gonna stop on this question. One of the reason is the mic is failing us. The second reason is that we need to have enough energy to pay attention to our our questions here. So if I do all the questions, you will get tired. I'm also gonna get tired, and I'm gonna make lots of mistakes. So we stop with question 1. We're gonna do question 2 tomorrow. I'll try to make sure that I have a good mic tomorrow. I'll work on it, or try to be quick enough so that the mic doesn't die on us, right? But are we happy with 1.5? Are you guys happy with 1.5? Right? And then if it so happen that you have questions, ask questions so that I can able to answer you based on those questions there. But before you do though, let's discuss the I'm still charging the mic. Can we discuss tomorrow? I'm thinking 4 o'clock. We do question two of this question. 4 o'clock, half past four. Let's do it half past four afternoon. Let's do this question. Let's do this question two tomorrow. So I'm gonna create a link, guys. So how about we do that? And people, they want me to share the memo, guys. The reason why we don't like sharing memos is because sometimes these memos, they have mistakes. So pay attention to some of the mistake on that memo. I hope you guys you will able to see them. But I will share the memo and also the question paper. Pay attention to the mistakes again. So let's discuss. While I'm charging the mic, let's discuss tomorrow half past. We are we are finished, people. I think it's best for us to stop here. Again, if you have questions, then you can remain here. I'm gonna try to answer some of the questions. So let's do it half past four tomorrow for question two. And if you can't make it, I will leave the video. It will be recorded there, guys. So you're gonna watch the video which is recorded. Unfortunately, I won't be able to answer your questions directly if you are at the if you're watching the video. So yes, people. What else? Oh, the link. I'm gonna leave the link of the channel for WhatsApp at the comment section when this stream ends. And also, I am going to um, share the question paper and the memo. Again, be very careful of these memos. We do make some mistakes while we are crafting them. So, just like when you go online and check the final paper memo, they do have some mistakes, guys, right? So, guys, uh, was this useful or less useful, my good people? Let me know so that I can improve there. I know that one of the things that I need to improve is the mic. So the rest, let me know. Let me know if there is something that we need to improve here, guys. So I'm gonna try to paste the link, guys. Okay, I'm gonna try to paste the link. I'm still trying to fix some things here, guys. But anyway, who has a question, guys? Who has a question before we switch off here, guys? Right? Who has a question? I'll send the link now, guys. I'm still trying to figure out how I'm gonna do it on the actual comment section, right? On the actual comment section, because I think it's best if we do it on the comment section, guys. Right? Let me see. Let me see, guys. This live stream is new. Okay, so you will see that there are a lot of mistakes that I do here. Uh, Tomorrow at 4:30, guys, the we'll do the question 2 of this question. Tell your friends, share with your friends, guys. If it was helpful, don't forget to say it was helpful. Also, guys, if you're still here, you can also type the college that you're coming from and the province. I believe that um, there are more than two colleges that are here in this chat, in this live stream. I think we have people from Free State as well. I think their lectures shared the link, right? So I hope you managed to 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 get the link as well. So I'm gonna share the link very soon, guys. Still working on how to do that. To be honest with you, guys, I'm working on it. I am working on it. Right, right. Let's do this. Let's do this. Let's do this. Gauteng, CJC Gauteng. Oh, nice, nice to have you here, CJC Gauteng. Right. Oh, Sasol Beck. Is it Flavius Moareka? Okay. So this, I think you are under Central Jobbik. Okay, CJC, CDB. All right. Flavius. Oh, that's cool. That's cool, guys. I see CJC and Flavius mostly. All right. Yes, people, just mention you because I don't want to only focus on the common paper because some people they might not be from Gauteng and Free State, and those people I don't want them to feel left out, guys. Right? TS TSC, okay, TSC. It's another college. All right, let's come here. We're still together. We're still together, my good people. Yes, it's quite a challenge, guys. But we will be fine, people. I'm still the reason why I'm busy saying things that I'm saying right now. I'm actually trying to figure out, guys, how to send you the link in a way that it won't I sent the link on the stream. I'm also gonna pin it on the comment section of this, right? If you have a friend who already logged out, tell them that the link is out, guys. Name, right? We have, I'm still reading the colleges here. Where is another college? We have West Call College. That's nice. Someone asked me about engineering N4, guys. Eesh, I don't know whether you're asking to do it here. Engineering info, I can't do it here for at the moment, guys. Right. And then we have someone from TNT, okay, and a lot of EWC students. I see you, EWC students. Katoras was problem. Yes, people, our mic is a problem, guys. We have to work on it. But by the way, there is a link there, guys. Share the link if you manage to saw the link. I just shared it. So I'm gonna share it on the comment. All right, people, thank you very much for watching and also being part of this live stream. We shall meet again tomorrow 4:30. The stream is over. So this is the QR code. Scan it if you want to be part of the WhatsApp. I am going to share the memo and also the question paper there on that WhatsApp group. Scan it, join it, and then I'm gonna share the the memo and the question paper. Right, people? Thank you very much, guys. Till tomorrow.